Right under our feet, literally every single second of the day, there's this insane cosmic balancing act going on that is, frankly, keeping us all alive. Welcome to This Explainer. Today, we're diving straight into one of the absolute most fundamental mysteries of our universe, the precise mechanics of gravity, motion, and this mind-bending concept of the perpetual fall. By the time we're done here, the way you view our planet's journey through space is going to completely change.
So I want you to think about a number for a second. 333,000. That's not just some random statistic. That is exactly how many times heavier the sun is compared to the Earth. I mean, it's just massive. And when an object is that incredibly heavy, it generates a gravitational pull that completely dominates our entire solar neighborhood. It is constantly, relentlessly tugging on our planet.
Which, naturally leads to a pretty obvious question, right? A huge paradox. If the sun is 333,000 times heavier than us, why doesn't the Earth just fall into it? Well, it turns out that figuring out the answer to that specific question led to one of the most elegant, mind-blowing discoveries in the history of science. To really wrap our heads around this, let's talk about the gravity paradox. Basically, the Earth is locked in this intense, eternal tug-of-war with a giant star that outmatches our weight by just a staggering, ridiculous degree. So, how on earth does our planet survive that? How do we escape that invisible inward pull? Okay, so at the absolute heart of this paradox is gravity. That invisible force that constantly attracts objects toward one another. Every single moment, that force is pulling us straight toward the sun. But as terrifyingly overwhelming as that massive pull might seem, it's actually absolutely crucial. Without it, planets wouldn't be able to hold a path at all. We just sort of drift off into the freezing, empty void of deep space. Yikes. So if gravity is yanking us inward, but we aren't crashing in a fiery doom, there has to be a missing piece to the puzzle, right? Something keeping us safe. To uncover the real secret behind our orbit, we have to look really closely at exactly how the Earth behaves while it's under all this immense cosmic stress. And that missing piece? It's the number 30. See, Earth isn't just sitting there patiently waiting to be pulled into the sun. It's actually moving sideways at nearly 30 kilometers every single second. Literally, every time you blink, our planet just traveled another 30 kilometers sideways. It is this phenomenal, blinding lateral speed that acts as our ultimate defense mechanism. It's kind of like a two-step cosmic dance. Step 1, the sun's gravity is constantly, endlessly pulling the Earth inward. Step 2, the Earth's sheer forward momentum is pushing it sideways at that crazy 30 kilometers per second. And when you combine that unending inward pull with that intense sideways motion, the two forces balance out perfectly. And that sweet spot, that exact balance, creates the sweeping elliptical path that we call an orbit. Now, to ground this massive, mind-boggling cosmic scale into something a bit more relatable, let's use a super simple everyday physics model. I like to call it the string analogy. Just picture yourself standing outside, swinging a ball attached to a piece of string in a big circle around your head. Believe it or not, the exact mechanics governing that little swinging ball are basically identical to what keeps our entire planet in place. Think about it. As you swing it, the string is constantly pulling the ball inward towards your hand, right? But the ball's own momentum is trying to carry it straight forward, away from you. That tension right there forces the ball to travel in a circle. In our solar system, the sun's gravity is acting exactly like that string. The only really mind-blowing difference here is that out in the vacuum of space, there's no actual physical tether. It's just the completely invisible force of gravity doing all the heavy lifting. To truly appreciate how incredibly delicate this balance is, let's do a quick thought experiment. What would actually happen if we just went ahead and broke the rules of our solar system's physics? Let's isolate the variables. Let's remove just one of these two forces to see exactly why both of them are so absolutely vital for our survival. Okay, let's look at the first extreme scenario. If the Earth suddenly just slammed on the brakes and lost its sideways motion, well, the sun's gravity would completely take over, and it would pull us directly straight down into a giant ball of fire. Not great. Now, what about the reverse? If the sun's gravity just magically disappeared tomorrow, cutting that invisible string, Earth's forward momentum would instantly shoot our planet off into deep space in a perfectly straight line. Also not great. Understanding this fragile balance causes a total paradigm shift when you think about our nice, stable, predictable orbit. I mean, we usually picture planets as just sort of safely floating along on a cosmic track. But when you factor in that immense gravitational pull and our extreme velocity, floating is literally the worst word you could use. What we are actually experiencing right now is a perpetual fall. Just let this realization sink in for a second. Literally every single second of every single day, Earth is falling toward the sun. But because it's moving sideways so incredibly fast, it just keeps missing. We are actively plummeting toward a fiery giant that is 333,000 times heavier than us. But because the curve of our fall perfectly matches the curve of the sun itself, we fall but we never actually hit. That continuous perpetual miss, that is the exact reason why life on Earth can exist at all. So, as we wrap up this explainer, it leaves us with kind of a wild thought to chew on. What else is endlessly falling through space? Think about it. Every single moon orbiting a planet, every distant planet orbiting some far-off star. They're all locked in this exact same cosmic dance, falling constantly, moving at breakneck speeds, and just endlessly missing. So the next time you look up at the night sky, I really hope you see all those glowing little points of light with a totally new perspective on the magnificent perpetual fall that is quite literally holding our entire universe together. Thanks so much for joining me, and hey, keep observing the wonders around you.